You ever stop and think about what's actually going on behind your TV screen? I mean, you press a button and a picture shows up. Simple, right? Well, it's actually the end result of a massive global tech upgrade, one that got a little messy. So let's pull back the curtain and figure out this whole digital TV puzzle.
Oh man, for a lot of us, this is a real throwback. Fiddling with the rabbit ears, seeing those weird ghost images of the news anchor, and then just snow. That whole world, the television we grew up with, it's pretty much gone.
And right here, this is where the plot thickens. Everybody knew analog TV had to go. The upgrade was obvious, but agreeing on what to replace it with, yeah, that turned out to be a whole other can of worms.
So to really get what's happening now, we have to take a quick look back at the old way of doing things. The big problem with analog TV wasn't just the fuzzy picture. It was incredibly wasteful. It had this one giant limitation that digital was perfectly designed to fix. This right here is the whole ball game. Look at that. With the old analog system, one frequency in the airwaves got you one channel. That's it, one for one. But with digital, suddenly that exact same slice of frequency could carry a whole bunch of channels all at once.
The secret sauce that makes this possible is called multiplexing, or just MUX for short. You can think of it as a way to digitally shrink wrap and bundle several TV channels into one neat little package so they can all travel together. This was a total game changer for broadcasting. And honestly, this is the perfect way to picture it. Analog TV was like a single-lane country road. Bumper to bumper, only one car can pass at a time. Digital came along and turned that road into a 6-lane superhighway, letting way more traffic, more channels, better quality, flow through the exact same space.
So, boom, we've got this amazing new technology, this superhighway for television. A new digital era had begun, and the next step seemed pretty clear.
I mean, you would think so, wouldn't you? It just makes sense. The whole world gets together, agrees on one single unified system, and everybody's happy. But, nope. That is not what happened. Instead of one clear road, the world basically split. Different countries and entire continents looked at the options on the table and went in completely different directions. And that decision is what created the complicated digital map we have today. Okay, so let's meet the Big Four. These are the major competing standards that carved up the globe. Their names are a bit of an alphabet soup, but they're the reason your TV works or doesn't, depending on where you are in the world. You've got ISDB-T, which kicked off in Japan. Then there's ATSC, that's the one they use in North America. DVB is the super flexible system that took over Europe, Australia, and a lot of other places. And finally, there's DMB-T/H, which is China's homegrown standard. Now, what's so interesting is that even though these systems were competitors, most of them were built to solve the same problem. They were designed to fit inside that old 6 megahertz space that a single analog channel used to occupy. It's like they were all trying to build a better engine that would still fit under the old car's hood. This table gives us a really great at-a-glance look. You can see ISDB-T in Japan and South America is really known for building mobile TV right into its DNA from the start. ATSC in North America took a totally different technical path with its single carrier design. DVB is like the Swiss Army knife. It can do terrestrials, satellite, cable, you name it. And DMB-TH in China really focused on broadcasting to both big screens and handheld devices. So, what's the big deal? What actually makes them so different from each other when you look under the hood? Well, it really boils down to one major technical choice about how they send the signal through the air. All right, so 3 of the 4 systems, basically everyone except North America, went with a method called OFDM. It chops the signal up into thousands of tiny little pieces. The big advantage here is that it's fantastic at handling signal bounce, the digital version of those old analog ghosts. But the ATSC standard in the US and Canada, they went with one big, powerful carrier. It's a simpler, more brute force approach, which has its own set of pros and cons. Okay, so we've got multi-carriers and single carriers and a bunch of acronyms, but so what? How does this global tech mess actually impact you, me, and the TV in our house? Well, here's the bottom line. First, this is the reason you can't just buy a TV in Japan, bring it to the US, and expect it to pick up local channels. They're literally speaking different languages. It's also the reason we have subchannels like 5.1, 5.2, 5.3. That's that MUX multiplexing thing we talked about in action. These standards also dictate whether you can even watch broadcast TV on your phone.
And maybe most importantly, this whole digital switch is what made it possible to go from those old squarish TV shows to the beautiful widescreen HD we have today. And you know, this story isn't over. It's not like these standards were decided back in the 90s and that was that. As this quote points out, they are constantly evolving. ASTC 1.0 is now giving way to ASTC 3.0. DVB became DVB-T2. It's this continuous process of improvements built right on top of the old ones. Which brings us to the elephant in the room. After all of this work, this incredible, complicated, global journey to perfect over-the-air TV, we're all just watching Netflix, right? In a world of internet streaming, what does the future even look like for the original way we all watch television? It's a heck of a question to think about.